Today in Storage Universe, we are going to talk about Snowflake. Here is a quick info about Snowflake. The important thing to note here is it's written in C++ and Java and embeds or uses Foundation DB. So Snowflake is a cloud-based database and is currently offered as a pay-as-you-go service in Amazon Cloud. It is developed by Snowflake Computing. Snowflake adopts a shared nothing architecture. It uses Amazon S3 for its underlying data storage. It performs query execution within its elastic clusters of virtual machine called virtual warehouse. The cloud service layer stores the collection of services that manage computation, clusters, queries, transactions, and all the metadata like database catalogs, access control information in a key value store called Foundation DB. So here is a high-level architecture of Snowflake. Snowflake is composed of a three-layer design with separate storage, compute, and cloud services layers. This architecture excels because while compute and storage resources are physically separate, they are logically part of a single, tightly integrated data platform system that provides non-disruptive scaling. Now let's look at the storage layer of the Snowflake architecture. The storage layer performs the following steps when data is loaded. First, it splits the data into micro partitions, hundreds of thousands of partitions per data file. Second, it extracts metadata such as timestamp and min-max values to enable efficient query processing. Third, it compresses the micro partitions to save storage and space costs. Fourth, fully encrypts the data using a secure key hierarchy. Coming to the compute part of Snowflake architecture, this compute layer is the Snowflake muscle. Compute engines designed to process large quantities of data quickly and efficiently perform all data processing. Compute engines do the following when performing a query. First, they retrieve the minimum data required from the storage layer to satisfy queries, as dictated by Snowflake's data pruning algorithm. Second, they cache the data and query results locally, delivering significantly faster performance and lowering cost. Third, unique to Snowflake, multiple compute engines can simultaneously operate on the same data with full system-wide transactional integrity and complete ACID compliance. Across any number of isolated workloads, read operations always see a consistent view of data, and write operations never block readers. Coming to services part of the architecture, the service layer is the brain of Snowflake. It is constructed of stateless computing resources running across multiple availability zones. This layer provides a highly available and distributed metadata store for global state management and enables Snowflake advanced services such as data pruning, data exchange, and cross-cloud data replication. The services layer also provides security and encryption key management and enables all SQL, DML, and DDL functions. The services layer is responsible for authenticating user sessions, providing management, enforcing security functions, performing query compilation and optimization, and coordinating all transactions. Here are the key benefits of Snowflake. The left column enumerates the benefits, the right column explains why it is important. If you're interested, you can pause the video and read them. Moving on. The implementation of Snowflake began in late 2012 and has been generally available since June 2015. In terms of concurrency control, Snowflake supports MVCC, that is multi-version concurrency control. As Snowflake's underlying data storage is done by Amazon S3, each write operation, instead of performing writes in place, it creates a new entire file including the changes. The stale version of data is replaced by a newly created file but is not deleted immediately. Snowflake allows users to define how long the stale version will be kept in S3, which is up to 90 days. Based on MVCC, Snowflake also supports time travel query. The main difference between multi-version and lock models is that in MVCC, locks acquired for querying, that is reading data, don't conflict with locks acquired for writing data. So reading never blocks writing and writing never blocks reading. Snowflake is relational as it supports ANSI SQL and ACID transactions. It offers built-in functions and SQL extensions for traversing, flattening, and nesting of semi-structured data, with support for popular formats such as JSON and Avro. When storing semi-structured data, Snowflake can perform automatic type inference to find the most common types and store them using the same compressed columnar format as native relational data. Thus, it can accelerate query execution on them. Snowflake supports defining and maintaining constraints, but does not enforce them except for not null constraints, which are always enforced, including foreign key constraint. Snowflake does not support index, as maintaining index is expensive due to its architecture. Snowflake uses min-max based pruning and other techniques to accelerate data access. Note, an index is a database structure that you can use to improve the performance of database activity. If you want to read more, refer to the Wikipedia link listed below. In terms of isolation, it supports snapshot isolation. However, according to the documentation, it is said that read committed is the only isolation level that is supported. Note, in databases and transaction processing, snapshot isolation is a guarantee that all reads made in a transaction will see a consistent snapshot of the database, and the transaction itself will successfully commit only if no updates it has made conflict with any concurrent updates made since that snapshot. Snowflake supports hashjoin. Hashjoin is a way of executing a join where a hash table is used to find matching rows between two inputs. An input is one or more tables. It is typically more efficient than nested loop joins, especially if one of the inputs can fit in memory. In terms of query compilation, it doesn't support any query compilation. A compilation is a process when a stored procedures query execution plan is optimized based on the current database and database object state. This query execution plan is then stored in cache and can be quickly accessed. When a query is executed, it's sent to the parser first. In terms of query execution, it uses a vectorized model. Snowflake processes data in a pipeline fashion, in batches of a few thousand rows in columnar format. It also uses a push instead of a pull model, as the relational operators push the intermediate results to the downstream operators. Note, a standard query execution system processes one row at a time. This involves long code paths and significant metadata interpretation in the inner loop of the execution. Vectorized query execution streamlines operations by processing a block of around 1,000 rows at a time. Within the block, each column is stored as a vector. Simple operations like arithmetic and comparisons are done by quickly iterating through the vectors in a type loop with no or very few function calls or conditional branches inside the loop. Snowflake supports SQL query interface. SQL is a domain-specific language used in programming and designed for managing data held in a relational database management system or for stream processing in a relational data stream management system. In terms of storage architecture, Snowflake is disk-oriented. Snowflake's data storage is done via Amazon S3 service. Upon query execution, the responsible work nodes uses HTTP-based interface to read-write data. The worker node also uses its local disk as a cache. Snowflake uses hybrid storage model. Snowflake horizontally partitions data into large immutable files which are equivalent to blocks of pages in a traditional database system. Within each file, the values of each attribute or column are grouped together and heavily compressed. A well-known scheme called packs or hybrid columnar. Each table file has a header which, among other metadata, contains the offset of each column within the file. The stored procedures are not supported in Snowflake. A stored procedure is a set of structured query language statements with an assigned name, which are stored in a relational database management system as a group, so it can be reused and shared by multiple programs. In terms of system architecture, it's a shared disk architecture. Snowflake uses Amazon S3 for its underlying data storage. It performs query execution within its elastic containers of virtual machines called virtual warehouse. Upon query execution, virtual warehouse uses HTTP-based interface to read-write data from S3. The cloud service layer stores the collection of services that manage computation clusters, queries, transactions, and all the metadata like database catalogs and access control information in Foundation DB. Snowflake supports virtual views. In a database, a view is the result set of a stored query on the data, which the database users can query just as they would in a persistent database collection object. This pre-established query command is kept in the database dictionary. A virtual view of the data is a virtual database defined by a SQL data service that you can query as if it were a physical database. To create a virtual database, you define a SQL data service in the developer tool. Here are some of the Snowflake alternatives. First is Amazon Redshift, then Google BigQuery, Azure Synapse Analytics, Databricks Lakehouse Platform, Deroid, and Vertica. Now here's the customer advice. If you're a startup, Yes, you can use Snowflake, but if you're already on a cloud service like AWS, Azure, or GCP, then use their service as it will be cheaper. For bigger companies, my advice would be to do an evaluation to see if it's cost effective, and Snowflake is really offering features and functionalities that is missing from the cloud service that you're using. Here are some references. And if you have any questions and suggestions, there is a two-step process. Subscribe to the Storage Space channel and leave a comment.